Cathode ray tube experiment. So here this is the discharge tube. So it is a glass tube. So this glass tube consists two metallic electrodes. One is cathode and another one is anode. So cathode is having a negatively charged and here it is positively charged, and anode is a perforated material, means it has hole. And so the glass tube has some partial side. So this is, we can call it as a vacuum pump. So the role of vacuum pump, we can evacuate any gas is present, if any gas will be present inside the discharge tube, and also we can introduce the gas for the study purpose. Okay, so these metallic electrodes are sealed, and so the beside the anode, so here a phosphorescence material. So here the phosphorescence material is made up of zinc sulfide plate. Okay, so these electrodes are connected through a high voltage battery. So this is the setup of cathode ray tube experiment. So what we observed in the experiment process. So when the discharge tube with low pressure, so that means 0.01 mm of Hg, low pressure, that is 0.01 mm of Hg, and high voltage, so high voltage, that is equal to 10,000 volts, that is equal to 10,000 volts. So here some rays are traveled from material of cathode to here. So these are some rays are traveled from here to here. So means the traveled from cathode to anode. So these rays we can call it as cathode rays. Clear? So the rays which are originated from cathode. So that's why these rays, several rays are moves towards cathode to anode. So these several rays we can call it as cathode rays. Okay, clear? You can see the rays are traveled from cathode to anode, so we can't visible with naked eye. So here this anode plate so has some hole. If these travels are traveled through this hole, so the backside of anode glass tube becomes heat. Okay, clear, students? So means here these rays which comes from anode to cathode, cathode to anode. So these rays are hit this zinc sulfide plate. So it becomes a glow, or it gives the bright color. So based on this brightness or glow, so we can conclude that these cathode rays are traveled from cathode to anode. So that is clear, right? So here the cathode rays originated from cathode material to anode material. So that is very, very important, right? So then we will move to the properties of cathode rays. Properties of cathode rays. Properties of cathode rays. Properties of cathode rays. Okay, clear, student? Right. We will discuss the properties of cathode rays. The first point you can see, that is the cathode rays move from cathode to anode. So that is the first point. The first property is cathode rays are move from cathode to anode. Clear? Right. If we can place any solid object here, we can place any solid object in the path of the cathode rays. We can place any solid object in the path of the cathode rays, so we will get the shadow of the solid object. So we will get the shadow of the solid object. So this concludes that the cathode rays moves or travels in a straight line. Cathode rays travels in a straight line. Cathode rays travels in a straight line. So here we can place any solid object in the place of cathode rays. So we can get the shadow of the solid objects. So that indicates that the cathode rays travels in a straight line manner. Okay, clear, student? Right. Then we can place when electric field is applied. So this is a negative. So this is, we can apply any electric field. So this is a positive electric field. We are applying positive electric field. So this we are applying electric field. So these cathode rays are deflected. Cathode rays are deflected positive side. The cathode rays are deflected positive side. So the deflection of positive side, the deflection of cathode rays on positive side, which indicates that these particles are having negatively charged. So it concludes that when we applied an electric field, so the cathode rays are deflected the positive of electric field. So which concludes that the cathode rays having negatively charged. Is it clear? Okay, right. So we can place magnetic field. So this is a north pole and this is a south pole. So here, so when we applied the magnetic field, so the cathode rays are deflected south pole side. The cathode rays are deflected south pole side. Okay, clear, student, right? So cathode rays are when an electric field is applied. When an electric field is applied, cathode rays are deflected positive side of electric field. Okay, clear, right? So cathode rays, when we can apply magnetic field. So when magnetic field is applied, cathode rays are deflected south pole side. So which is clearly says that the cathode rays are traveled from, means the rays are traveled from cathode to south pole. Okay, clear, right? If we can place any pedal or wheel, so here, so any pedal you can place here, so these cathode rays are having some kinetic charge. So when the lines are moves from cathode to anode, so this wheel is also rotated, means the pedal is rotated. Is rotated, so rotates, because here the kinetic energy is converts into mechanical energy. So clear, the kinetic energy which converts into mechanical energy, means the cathode rays having some kinetic energy. So this kinetic energy so can rotate the pedal wheel, so it converts into their mechanical energy. Okay, clear, student? Property is when a cathode rays or strike or hit this metal foil, later it becomes hot. So when the cathode rays are strike the metal plate, the later it becomes hard. So which indicates that the cathode rays produce heating effect. Clear? So these are the properties of cathode rays. Okay, so the rays once again we will discuss, right? Cathode rays moves from cathode to anode, and the cathode rays travels in a straight line. So we can observe when we can place a solid material in place of the path of the cathode rays. So we will get the object of this, we will get the shadow of this object. So which indicates that the cathode rays travels in a straight line manner, right? So when we placed, when we applied, so electric field, so the cathode rays are deflected, the positive plate of the electric field, so which indicates that the cathode rays are negatively charged. Okay, clear, right? So when we applied, so magnetic field, when we applied a magnetic field, the cathode rays are deflected on south pole side. Okay, clear, right? So then the next property, when we place a pedal wheel, so here, so these cathode rays rotate this wheel, so which indicates that the cathode rays is having a kinetic energy. So this kinetic energy can turns into this mechanical energy, so due to this rotation. Okay, clear, right? So the last property is when these cathode rays strike this metallic plate or hit this metallic plate, so the later the plate becomes hot, so which indicates that the cathode rays produce heating effect. Okay, clear?